Hello dear students, welcome to solid state physics lecture number 3rd. I'm Dr. Pervaiz Ahmad. Again in this section we will continue our discussions on crystallography. So here we will have a discussions on the crystal lattice, that what is crystal lattice and how we can make a crystal lattice out of particular crystal. So let's start our discussion with the crystal lattice. So just I mentioned, we will have to start our discussion from a question. What is crystal space or a lattice? I mean, we remember crystal lattice we also call crystal space. So here you can take an example, the platinum crystal. So in original, the platinum crystal it look like this. I mean, just like you can see it here. But if you observe this particular crystal of platinum under scanning tunneling microscope, so you can see the platinum surface just like this. And if you draw the crystallographic, the crystal lattice of the platinum, so the structure will look like this. So what is mean by the crystal lattice? We remember in crystallography, we only deal with the geometrical properties of the crystals. Therefore, one replace each atom by a geometrical point located at the equilibrium positions of that atom. So just like we mentioned in the previous lecture, that crystals, inside that is the crystallography is basically deal with the orientations of the atom inside a solid material, that is the arrangement of the atom inside a solid. So here we will further classify the concept of the crystal lattice. Let me further in easy word, let me further clarify it like this. What is mean by the crystal lattice? So here you can take the example of this crystal lattice, and how should I justify or how should I explain it? So in sample word, a crystal lattice is an infinite array of point and space. I mean, here you can see these are the point. I mean, it's a point A, this is the origin, this is a point A, this is a point B, and here you can see it's a point C, point D, point E, and so on. So these are different point in the space. So this is one thing. I mean, when we say what is crystal lattice, so we say this is the an infinite array of point and space. So what are the points? So here you can see we have different points. So these are different point and space. What we have further, so each point has identical surrounding to all other points. So here you can see, if for example we consider this point, so here you can see the surrounding, they are totally identical. I mean, the surrounding of this one is exactly the same as like of this one. And arrays are arranged in exactly in a periodic manner. So you can also see the periodicity. So these are the 3 points which one should remember while dealing with the definition or identification of a crystal lattice. So what is a crystal lattice? Now you can easily identify a crystal lattice, or you can easily memorize the concept of the crystal lattice. That is, it is an infinite array of point in space. So you can see here these are the point, and each point has identical surrounding to all the other point, which again you can see here the surrounding of all the point, they are identical, and arrays are arranged exactly in a periodic manner. So you can also check the periodicity by yourself. So crystal structure, what is mean by the crystal structure? So crystal structures can be obtained by attaching atoms, group of atoms or molecules, which are called bases or motifs, to the lattice side of the lattice point. I mean, that is how we can make a particular crystal structure. I mean, the particular crystal structure is made from the crystal lattice plus the bases. I mean, what is mean by the crystal lattice? The crystal structure. So the crystal structure is equal to the crystal lattice plus the bases. I mean, here you can see again in two dimensions. So these are the crystal lattice. So on the crystal lattice we just put the basis, so it gave us a crystal, a particular crystal structure. So again in two dimension you can see a two dimension Pervaiz lattice with different choices for the basis. So here you can see the Pervaiz lattice plus the basis, so that gives you the crystal, the exact crystal. So I think it's a very easy concept for a crystal structure. So what is mean by the basis? So basis is basically a group of the atom which describe crystal structures, and here you can see these are the bases. So here a situation of the atom at the corner of regular hexagon. I mean, here you can see, and here it be crystal lattice obtains by identifying all the atoms in A. I mean, here we just specified the point, and here the crystal lattice this crystal lattice is obtained by identifying all the atoms in the A here, I mean this particular structure. So crystal structures, you should not mix up atoms with the lattice point. Lattice point are infinitesimal point in space. Lattice point do not necessarily lie at the corner of the atoms. So crystal structures, you can see crystal is equal to crystal lattice plus the basis. I mean, whenever we are saying we have a crystal structure, so you have to keep in mind these 3 points. I mean, you should not mix up atom with the lattice point. Lattice points are infinitesimal point in space, and we remember lattice points do not necessarily lie at the corner of the atom. So in this context, the crystal structure is equal to crystal lattice plus the basis. So in summary, the crystal lattice, here you can see for yourself, crystal lattice is basically, we have two types, which is Pervaiz lattice and non-Pervaiz lattice. So what is mean Pervaiz lattice and non-Pervaiz lattice? By Pervaiz lattice we mean all the atoms are of same kinds and all the lattice points are equivalent. So here you can see these are this is a Pervaiz lattice. So it has the characteristic that all the atoms are of the same kind and all the lattice points are equivalent. What about the non-Pervaiz lattice? So atom can be of different kind. So here you can see we have these are one kind of atom, and in the middle here these are another kinds of atom. So some lattice points are not equivalent. So here you can see these lattice points, they are not equivalent. I mean, just like these one. These lattice points